Good afternoon, my favourite grade 10 bunch in the whole wide world. So, Mymaths, I'm going to go through this trig equations to my maths task, just to give you some information about the class. You know how I like to name and shame. Metha, Jude, Muhammadish, Maki did not attempt it. It's now Sunday, very disappointing. We had Rhoda, Noor and Sarah and Esther all probably have to redo it, especially the question 2 part, because you're in an orange. And a special shout out to Lou, who tried this task over 10 times and she finally succeeded in getting full marks. Well done to Lou. Anson and Amrit decided to cheat, and I think they just used the calculator to get all their answers because they didn't upload any evidence. So that kind of gives you a brief outline. Question 1, I'm not going to spend time on because that's one of the easier ones from the textbook in terms of when you do the square root. A lot of yous just need to remember that when you do the square root, it's going to give you the plus and minus of root 3 over 2. So that means when you work out your angles, you have to do it for plus root 3 over 2 and negative root 3 over 2, which gives you 4 different answers. The second one, I don't need to do either. Just need to remind you of putting it into a quadratic. So you just say let a equal cos x, and that will give you 2a squared plus root 3a equals 0. Or you just divide everything by cos x. So scrap that. It's not going to give you a quadratic. You just divide everything by cos x. So you end up with 2 cos x plus root 3 equals 0. And then cos x is just going to be equal to negative root 3 over 2. And it's negative, so you just got to use your triangles. So you don't even need calculator for the first one and the second one. The third one, you look like you do need calculator unless it's wanting you to do it graphically. And if you were to do it graphically, you would have to, it would be difficult to draw graphically because you would have an amplitude of 1.3 and negative 1.3. However, you would know approximately where the sine and cosine graphs cut, but the cosine would have a different amplitude. So I would just divide both sides by cos x. So for question 3, I would end up with sine x over cos x is equal to 1.3, which is equal to tan x equals 1.3. And then when you do inverse tan of 1.3, I think you get 52.4. And then 1.3 is positive, so you just do your all Scottish teachers are cool. And I have to remember the range is negative 180 to 180. So that means I'm going to tick the all quadrant and the tan quadrant, which is 180 plus x, and this is x. So I'm going to have an angle here, which is 52.4, and I'm going to have an angle here. Now 180 plus x is going to be outside of the range, so I can't use that one, but I can use the negative one, which is going to be negative 180 and plus x. So that's going to be, what's that, 127.6. And that there is your two answers with the negative. So x is equal to 52.4 and x is equal to negative 127.6. And then it wants it to the nearest whole number, the nearest degree, don't forget that, so you don't make any silly mistakes. That would be 52 and negative 128. Because you need to remember that if it's negative, you go in this direction, and if it's positive, you go in that direction. So this is me just repeating stuff that you should already know. The only tricky bit was dividing both sides by cos x, but you have done that in a textbook exercise. Right, on to the trickier question, which was the last one. And what I've discovered is that using algebra, solving a trig equation, you can only find two angles, and then the others you need to spot from the graph. So let's see how this goes. So that was part 3, sorry. This was question 1, this was question 2. Now going to do question 4 of this. So to solve this, I'm going to change tan x into sin x over cos x. And then I'm going to rearrange it so I end up with sin x over sin x. Now I would just say move the cos x up and the sin x down, so it gives me root 2 cos x, which is therefore going to give me 1 over root 2 cos x. So then, remembering my triangle, it's the 1, 1, root 2. It's the isosceles, which tells me this is 45 and this is 45. So inverse cos of 1 over root 2 tells me that x is going to be 45 degrees. So, bearing in mind the range, it's negative 180 to 180. If I do my cast diagram, sine, tan, cos, 45 degrees is going to be here and in this one. And if I do 180 plus 45, it's going to be outside the range again. So that means I'm just going to have 45 here. And if I think about the negative aspect, it's going to be negative 180 plus 45. Which is going to be negative 135. Oh, spotted why it wasn't making sense, because it's not tan, it's the cos quadrant. Silly me. So it's the cos quadrant. I was thinking it was tan x, it's cos x. So here, so it's actually much easier. So if it's 360 minus 45 is going to be outside of the range, so don't do that. So that means I need to think about the negative. So 0 to here is going to be negative 45. So that tells me that I've got x equals 45 and x equals negative 45. Now there's no other way using this trig equation to find the other values. So I found 1, 2, but there's another 3 that I cannot figure out just by doing that. So what I have to do is think a bit more, common sense. So if I look at the question, tan x equals root 2 sine x, well, if you draw the sine graph, you know that it goes up, down and back up. And if you draw the tan graph, you should remember that on the tan graph, if I make that 180, 90, 270, 360, the tan graph has asymptotes at 90 and 270. But regardless of that, it kind of comes up, goes in, and then back up. It comes up, goes in, and then back up. So you see that the tan graph cuts at 0, and the sine graph also cuts at 0. You can see that the sine graph cuts at 180, and the tan graph cuts at 180. So just by using a bit of common sense and knowing the graphs, I still haven't touched my calculator. I know that when I make these equal to each other, now yes, it's root 2 sine x, but all that means is the amplitude is root 2. That's still going to cut at the same angles. It's just the maximum minimum height has changed, but the intersections with the x-axis still remain the same. So I know that it's going to be x equals 0 and x is equal to 180. Now if I continue this into the negatives, what does the sign do? It goes down, back up and down. And a similar thing you can see is that if I repeat this with the tan, you're going to see that it crosses also at negative 180. So if I put in that as 90, negative 180, negative 360, and do those same lines, it's got an asymptote at negative 90 and an asymptote at negative 270, but the graph still goes up, along and up, along and up. So you can see that the sine graph cuts at negative 180 and the tan graph cuts at negative 180. So if I was to overlap them, they have the same intersection points. So my three values I've now got 0, negative 180 and 180. So let me see if I can draw that a wee bit better for you. Let's change colours. So if I did a bigger graph and put them on, now I'm not touching the GDC, I'm using this from my own knowledge. If this was paper 1, this would be absolutely fine because I haven't used the GDC. I would put in my root 2 to negative root 2, and then I would go up, down, and back up, and I'd go down, up, and back down. So you can obviously see that that's negative 180, 180, 0. So that's the 3 points that I'm talking about. Then here I can say that there's an asymptote. It won't allow me to do a dotted line, so I'll do that again. So there's an asymptote there at negative 90. There's an asymptote here at 90. There's an asymptote at 270. An asymptote at negative 270. So I've drawn my sine graph. I've got all my angles in. 0, 90, 180, 270, 360, 0, negative 90, negative 180, negative 270, negative 360. Now that all that's left for me to do is draw the tan graph. So I know that the tan graph is going to come down like that and down. Quite hard to draw the tan graph. It's going to come round and it's maybe not going to be as straight as that. It's going to ease towards it and up. Bit like Pac-Man, as I said. It's going to come up through up. So you can see, although my diagram's not the best, it comes up and then it kind of touches and then goes up. So it kind of crosses over at one point, which I know should be negative 45. So if I draw that a wee bit better, you can see that it comes up through and crosses. And then this one comes up, crosses, and then goes up and so on. So I think I've drew this a little bit. There's so many lines it's hard to see. So you can see that the two asymptotes are the green lines. So it should come up, along, and that. So it shouldn't really touch that red line, it's the intersection point. So that's where it's hard to kind of understand. And then obviously this one comes up, along, and up. So here, although it doesn't look like it from my diagram, it should only be touching one point here. It's just hard for me to draw. So those would be, the two yellow things are the negative 45 and the positive 45. This is 180, this is 0, and this is negative 180. And those are your 5 values. So that is a very tough question because I had to use trig to get the 45 and negative 45, and then I have to understand the graph. I didn't need to draw this big massive graph, I just wanted to kind of show you some intersection. I could have just looked at it with the two mini graphs I did using a bit of common sense. Alright people, I hope that helps you for trig equations part 1. So now on to part 2, which was a trickier one, I believe. So, let me change that. There we go. So we've got harder ones. It even says it in my maths task. So what we're going to do here. So it says solve these equations for, and then you should know your various exact values, your trig double angle rules, which are given to you in the formula. So the obvious one is sine 2x, but I'm just looking at this. Do we actually need to do it here? I see a double angle for the third one, but for the first one, do we need to use it? Let's see. So I'm just going to write a trig identity, so we know that tan x is equal to sine x over cos x. And we also know that sine squared x plus cos squared x equals 1. So I think that should be good enough for us to do these. Let's see. So if I rearrange the second trig identity, I can say that cos squared x is equal to 1 minus sine squared x. So if I look at question 1, it says 3, I'm going to just expand the brackets, minus 3 sine, and instead of writing theta, I'm going to just do x because it's easier for me to write, is equal to, and I'm going to change cos squared x into 1 minus sine squared x. Now, why did I do it? I did it so that it was all in the same notation with sine. So now I think I'm going to end up with a quadratic. Well, I already know that I've got a quadratic, but it should allow me to put it into the trinomial form. Excuse the messy pen. Right, let's bring it all to the left hand side and make the right hand side equal 0. So I end up with 2 sine squared x minus sine x, and then 3 minus 2 is going to give me plus 1 is equal to 0. So this is let a equals, so this time it will work, sine x, so I get 2a minus a plus 1 equals 0. So factorising, 2 times 1 is 2, what multiplies, so you could do it the long way, you can do it the short way, but this is obviously going to be 2a and this is going to be a. And then I want the negative one here because that would give me negative 2 and that's going to be plus 1. If you want to figure that out the long way, the way I've shown you in the past, that's fine. What multiplies to make the last the 2 but adds to make minus 1, you could have wrote minus 2 and 1. And then you could have broken it down from there, but I'm just taking a shortcut. So therefore, I've got 2a plus 1 equals 0, and a minus 1 equals 0. So I end up with, let me just jump a step, a equals negative a half, and a equals 1. So remember what I labelled a is equal to sine x, so I've got to change back. So I've got to say that sine x equals negative a half, and sine x equals 1. So if you wanna, you can use the cast diagram here. If you wanna just draw the graph, the sine graph, you could just work it out from there. I'm looking for 3 possible answers. Sine x equals 1 is an easy one. So if I just draw it, and it's in the same range, they're always given as negative 180 to 180. Oh, my jaggy peaks. So here is 1 obviously, and here's negative 1. So if I was to put a line across 1, which is here, this is outside of the range, so I don't need it, so it's going to be that one, which is clearly 90 degrees. So just by knowing the sine graph, you know that it's a maximum of 1 at 90 degrees. It's also at negative 270, but we don't need to worry about that. That's within the range. Now, negative a half, you could again draw a line here for negative a half approximately, and you could hazard a guess at it, but why do that when you can just use your cast diagram and be a bit more precise, and also your triangle. So if I've got a triangle, 1, 2, root 3, and its sine, then it's obviously going to be 30 degrees. But 30 degrees is not for the negative, 30 degrees is for the positive. So I can say that if I want the negative one, it's going to obviously be in my cast diagram. So here's 30, but I don't want that one. I want the two negative quadrants, so it's going to be in here and going to be in here. It's going to be negative 30. It's going to be 180 plus 30, which isn't going to work. It's 360 minus 30 is not going to work. Those are going to be outside of the range. So that means it's going to be negative 180 plus 30, which is negative 150. And 30, sorry. That's it, yeah. No other ones are going to be in the range because 210 and 330 are outside of the range. So I've got 90, negative 130 and 150 as my three answers for question 1. Okay, so if I just rub out this cast diagram, that'll give me more space here. So number 2, let's see how I can fit it in here. Number 2 says 2 plus 7 theta, 7 cos theta equals sine squared. So I'm going to remember above sine squared theta plus cos squared theta equals 1. So rearranging that, sine squared theta, I'm going to stick with x, is equal to 1 minus cos squared x. So that gives me 2 plus 7 cos x equals 4 bracket 1 minus cos squared x. So I'm going to get a quadratic again. I'm going to bring it all to one side, and because I'm running out of space, I'm going to skip a step. So I should have 4 cos squared x on this side plus 7 cos x here, and then I've got 2 and minus 4 is going to give me minus 2 equals 0. So I'm going to let a equal cos x, so I'm going to end up with 4a plus 7a minus 2 equals 0. So multiply the first and last term, that gives me negative 8. What multiplies to make negative 8 but adds to make plus 7? Well, that would be 8 and negative 1. So that gives me 4a plus 8a, 4a squared that is, plus 8a minus 1a minus 2 equals 0. Factorise the first two, then factorise the second two, so it's going to be 4a bracket a plus 2 negative a, oh, my battery's died on my pen, a plus 2. How do I know I'm right? Because the two brackets are the same, so I'm going to end up with 4a minus 1 and a plus 2. So I end up with a is equal to a quarter and a is equal to negative 2. Now, because I'm dealing with let a equal cos, I need to remember we did that, I didn't write it, let a equal cos x. I need to put this back in, as I said before, so I end up with cos x equals a quarter and cos x equals negative 2. Well, we know that the cos graph only goes up to one negative one, so therefore this one is ruled out, which leaves me with cos x equals a quarter. Now, there is no triangle to help us out with cos x equals a quarter, so therefore you can use your calculator for this one. So inverse cos of a quarter gives me 75.5. So x is equal to 75.5. And as for my answers to the nearest degree, and I'm looking for two possible answers. So if I'm looking for two possible answers, all sine, tan, cos, a quarter is positive, so it's that and that. But what you need to remember is that the cos graph is symmetrical as well. If you remember, it goes down, up, down, down, up, down. If a quarter is about here, then the two angles is this one and this one. So if that one's 75.5, then I also have to have the negative of that. So that's going to be 76 and 76. So that's that one done. Two possible answers, the rest are outside of the range. Right, on to the last one. I hope this gives me enough space. I've got 2 cos squared 2 theta. 2 cos x. Oh, it's going to be 2x in there, double angle, plus sine 2x equals 1. So, various things you could think about in your brain here. You've got sine 2x, which you can remember the double angle rule, that sine 2x is equal to 2 sine x cos x. You've got cos squared 2x, which allows you to say that cos squared 2x plus sine squared 2x equals 1. You still know that. And also you could say to yourself that sine 2x over cos 2x equals tan 2x. So I've got all these things flying about my head. What one am I going to go with? If I made sine 2x into 2 sine x cos x, and then changed cos squared 2x into 1 minus sine squared x, it's not going to work. So let's see, if I do 1 minus sine squared 2x plus sine 2x equals 1. Then expand that out, that gives me 2 minus 2 sine squared 2x plus sine 2x equals 1. Okay, I'm going to make this side 0 and bring everything else over. So 2 sine squared 2x negative sine 2x, and then that would be negative 1 here. So then I can say that let a equal sine 2x. So 0 equals 2a squared. And minus a minus 1. Now if you look above, that's the same format. 2a squared minus a plus 1. This one's minus 1. So that means I've actually made a mistake up here, just looking at this. If that's plus, then that should have been negative 2 what multiplies to give 2. Sorry, I'm just going back to question 1 here and checking over this. 3 minus 3 sine x equals 2 bracket 1 minus sine squared x. If that's 2 minus 2 sine, bring that over, that becomes positive. That remains the same. And then 3 minus 2 is 1. So 2 times 1 is 2. What multiplies to make 2? 2 and 1, but adds to make negative 1. Nothing. I feel like my answers are right, but I've made a sign mistake. Oh, that's it. I see, I've missed out the 3. My handwriting's so bad. It's minus 3. So what multiplies to make? So that should be negative and negative. So that means that that should be negative 2. That would give me negative 4. No. So let's reverse it. Let's change that. So that would be negative 3. 2a squared negative 3a plus 1. So what multiplies to make 2 but adds to make minus 3? So that's right. So then that would be 2a negative 2a. That would be squared. Negative a plus 1 equals 0. So that would be 2a bracket a negative 1. And that would be negative 1 a minus 1. So was I right? A minus 1 and 2. That's it. That should have been a negative, which makes that a plus, which is then going to change this line and these numbers. So it's positive a half. Oh my goodness. I'm not redoing this video, so you're just going to have to fast forward. I hope that when you were actually watching me do question 1 the first time, you were thinking, oh, he's made a mistake. And now you can fast forward and see that I've changed it. So that was plus a half, which if I use my cast diagram, which I did before, it's going to be in the all quadrant and the sine quadrant. So it's going to be 180 minus 30, which is 150 and 30. Oh my goodness. Glad I got to the bottom of that. So it's not the same, it's different. So let's see, keep going with this. So this says negative 2. What multiplies to make negative 2 but adds to make negative 1? That would be negative 2 and 1. So 0 equals 2a squared negative 2a plus a negative 1. So 0 equals 2a bracket a minus 1 plus 1 bracket a minus 1. So that gives me 2a plus 1 and a minus 1. So I've now got my 2a plus 1 equals 0, a minus 1 equals 0, so a equals negative a half and a equals 1. So it's actually similar to what I had up here with plus a half and 1. But this is negative a half and 1. And it's sine, but that one was sine. Oh my goodness, they're all linked. So substitute it back in. This time I've got sine 2x equals negative a half, and sine 2x is equal to 1. So just for you to understand what sine 2x looks like and what sine x looks like, let's draw a little graph. So sine x is obviously just our standard, but sine 2x means that it's going to be 2 cycles. So there's 90, 180, 270, 360. So that means there's going to be, I only want to go to 180 and negative 180. So that means that one whole sine curve is going to go to 180. Negative 90, 180. And then this one's going to go down, up, and back down. So I don't actually need the other ones. So when it's 2x, it means that there's 2 cycles between 0 and 360, which if you want I can continue. So now there's 2 cycles, but I don't need the last cycle because I only want it within the range of negative 180 to 180. So how many answers am I looking for? Looking for 6 possible answers. So let's see if we can get 6 possible answers. Well, if I'm looking for sine 2x is 1, well here is 1 here. So if I put a line across 1, that gives me 2 possible answers right there. Well, if sine x is normally at 1 at 90 degrees, then sine 2x is obviously just going to be half of that, so 45. So this angle here is going to be 45. And this angle is going to be 1 at, I'm guessing, negative 135. How did I know that? Well, there is 180 and it's 45 down from that. So if I want to do it if I want to do it using my cast diagram, well, I know that it's at 90 here and negative 90 is here. So if I just divide that by 2, but it wouldn't be negative 90 for 1, it would be negative 1 and negative 90. Then at 180 is 0. Yeah, so it would be negative 270. So here is when it's at 1. So by dividing negative 270 by 2, I get negative 135. So that gives me that one. So that's done. So now on to a half. I'm going to do this the proper way. If I've got space, I'm going to do it algebraically, which is the way I prefer anyway. So what is sine a half? Well, we've already done that in a triangle already. We should know that it's 30 because it's 1 and 2. But it's negative. Now we did negative earlier, if you can remember. We'll do it again anyway. So sine 2x, I'll just remove the sine of that because we want just 2x. We already know that it's going to be 30 in the positive quadrant. So what is it when it's negative? Tan and cos tell me that it's 180 plus 30, which is 210. And 360 minus 30 is 330. But I also need to know that it's negative 30 in the negative part, and it's going to be negative 150. So that's given me 4 possible answers. However, I want to find out what it is for x. So I need to divide all these by 2, which gives me 105. It gives me 165. It gives me negative 15. And it gives me negative 75. Phew! We got there. So I've got 1, 2, 3, 4. And then 5 and 6. Let me just write those final ones, which was 45 and negative 135. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, I'm not sure whether they give you the exact same equations in the Mymaths task, but that has taken me some time to explain it to you. It wouldn't take me this long if I was doing it myself. I'm trying to think of all the possible ways to make it easy for you to understand. But hopefully that's helped, guys. I will put this video up now and you can try and redo the task without looking at my video. Watch the video and then see if you can do it without watching it. And for Metha, Jude and Mohammed, I expect this to be done ASAP.